So the next unit that we will be on is called ionic bonding. So that would be the title, and you can see that on your notes there. So to review a little bit of last chapter, first thing that we talked about would be that anions are what charge? They are negative. And cations are positive. And remember, the T in cation looks like the positive symbol, hence why it's a positive. That's just my way of remembering which one's positive and which one's negative. So also we learned that compounds have what for a charge? They have a zero charge. So if you have a zero charge, that means that you are neutral. So that's what you put on the last line there. So 0 and neutral. So since we're kind of reviewing again, next step of review, we'll be talking about valence electrons. Remember, valence electrons are known as the outermost electrons, or the electrons with the highest energy level. So we talked about column 1A on the periodic table. And column 1A has how many valence electrons? Or how many dots, as we were talking about with covalent bonds. Column 1A has 1 dot, or 1 valence electron. And this means it has what? For a charge. It has a 1 plus charge, because it wants to lose that 1 dot. Now, looking at column 2A, what happens to charge there? So column 2A has a 2, or number 2 dots, 2 valence electrons, so it has a 2 plus charge. So again, we've already talked about this, so that means that column 3A would have what exactly? And again, since we've already talked about this, I can erase these here. Column 3A would then have 3 valence electrons, and it has a 3 plus charge. We talked about column 4A and how 4A can be either positive or negative. So now let's move on to 5A. So looking at column 5A, we now have 5 dots, or 5 valence electrons. And we learned last chapter that if you have over the number 4 when it comes to valence electrons, the charge is now going to be negative. So that means we're trying to get to 8 total dots, so that's a 3 minus charge. So as you see in your notes packet there, I gave you a picture of the periodic table. Group 1 has 1 plus electrons. Group 2 has 2 plus. Group 3 has 3 plus, and so on. So it's just there to help you. Alright, so at the bottom of your notes on the first page, now we're talking formula units. So basically this is the label for what's going on in an ionic compound. So formula units. So basically it is the lowest whole number ratio of ions in an ionic compound. And I gave you some examples there. I said NaCl has a 1-to-1 ratio. Now, why is that? Well, you have one Na and you have one Cl, so it's a 1-to-1. The other example on there is MgCl2, and they're saying it's a 1-to-2 ratio. And why is that? Because you have one magnesium and you have two chlorines. So it's pretty simple. It's just a definition talking about the separation of an ionic compound. Now moving on to the back side of your notes, the next thing talking about is names of ions. Okay, so metal ions are very easy. Okay, you just use the element name from the periodic table. So you want to fill in the word element on your line. So for an example, if you had Na+, this is just a sodium ion, which is pretty simple. Now, for non-ions, it's also very simple. We're going to use the beginning or use the first part of the element name. And what do we change the ending to? Excuse me. So we change the ending to what? Anybody remember? We're changing the ending to IDE. All right, and the example I gave you there would be nitrogen changes to nitride. And we did that last chapter with naming covalents, so that should be pretty straightforward. So we're almost done. The next thing on there is the octet rule. We also briefly talked about this last chapter. So every element, or all the elements, want to be like which set of elements on the periodic table? All the elements want to be like the noble gases. All right, so they're always trying to be like the noble gases. And why? Why do they want to be like the noble gases? All right, it's because they want 8 electrons. Once they have 8 electrons, that means that they would be full. All right, so we're now going to move on to ionic compounds. So ionic compounds are different from covalent compounds. So ionic compounds are formed between a metal and a non-metal. By transferring electrons. All right, so they want to transfer their electrons. And I give you an example on your sheet, so let's quickly just do the example here. So the example you have there is NaCl. Now, Na has 1 dot, but Cl has 1, 2, 3, 4, 5, 6 dots. Or excuse me, 7 dots. So I have my 7 dots and my 1 Na, so it transfers to chlorine. It gives up its electron so that it can be NaCl. And since NaCl is a crystalline structure, it looks like this. right, and this is called a lattice structure. So just make sure you draw that off to the side. All right, so the last thing we're going to talk today about is just ionic bonds in general. So ionic bonds have a few properties. So because cations, which are positive, and anions, which are negative, are oppositely charged, they attract to each other. Okay, so there's like having a magnet with the north end being close to the south end, they'll be attracted to each other. And there's also a few other properties about them, so on your pen, fill them in. So ionic bonds are crystalline. So ionic bonds are crystalline, meaning they look like crystals because they're solids at room temperature. And because they have a lattice structure, they are hard, and they have high melting points. Also, they conduct electricity. When dissolved in water. So they conduct electricity when dissolved in water. And why? And it's because the charge is distributed. So for an example, if I said there's a compound, so we'll call it compound X, is hard and melts at 1,000 degrees Celsius. Do you think that's ionic or covalent? Because it's both hard and melts at a really high temperature, that means it would be an ionic compound. And that's the end of notes for today.